Welcome to the Infinite Women podcast. I'm your host, Allison Tyra, and today I'm joined by CSIRO's Dr. Denis Bauer, whose work focuses on improving human health by applying cloud computing technology to better understanding the genome. And we will dig into that research a little bit later, but first we're going to chat about one of Dr. Bauer's scientific forebears, Rosalind Franklin. So let's start with, what is the significance of Rosalind Franklin to the field of genetics?
Yeah, Rosalind um, was the first to actually use the X-ray diffraction images in order to look at DNA crystals. And she did that at the King's College in London. And this really um, was improving the techniques that were there already before, but this time to get a clearer image of the actual DNA. Therefore, out of this came the infamous photo 51, which her student Raymond Gosling was taking. And it really showed how the crystal actually looks like. And from there, they could deduct that it must be a helical structure, so which is the famous double helix that we all know the DNA looks like today. And this work was really done at the same time as Watson and Crick.
And for anyone who's not aware, Francis Crick, James Watson, and Franklin's colleague shared the Nobel Prize in Physiology or Medicine in 1962 for essentially what we're talking about, identifying the structure of DNA. But it seems like all her colleague actually did was just give the image that her student took using her techniques to Crick and Watson. So I would question why he was getting the Nobel.
Yeah, the way that I think research in general works is that you come together and you talk about things, and then ultimately it's sort of the effort of multiple people, and it's really hard to identify whose contribution was exactly what and how it has led to a certain discovery. So my understanding of how things were back then is that um, Rosalind and her student Raymond, they got this image and they hunkered down to actually calculate the exact structure from that image, and that took them quite some time. And at the same time, Crick and Watson and Franklin's colleague Wilkins were working on a rough approximation of it, and therefore, when they saw that image, it sort of sparked that epiphany probably in their mind that hey, it could be a double helix, and therefore it was published. Their work were published back to back. The Watson and Crick were in the journal, as well as Rosalind's pure, beautiful calculations were in the journal. And then I think why she didn't get the Nobel Prize was really boiling down to that she unfortunately died before it was awarded in 1962. So she died 1958 at 37. And therefore, the Nobel Prize is not awarded um, posthumously. So therefore, I think it's we can only speculate whether at the time she would have gotten it or not.
Yeah, and it's interesting to note that when she died, she was only 37, but she was leading pioneering work on the molecular structure of viruses. And her teammate, Aaron Klug, continued her work, and he then won the Nobel in chemistry in 1982. It's crazy to me that, she was part of Nobel Prize winning work twice in two different fields before the age of 40. Like, that's nuts.
Absolutely. I mean, this really attests to her brilliance, right? That she can think so fundamentally and research so fundamentally improving, has fundamentally improving work in two different fields. And she probably would have, right, moved on to have even more insights and more contributions to science if she did not die so early. Um, so yeah, it really attests to that, to her brilliance.
And when I read her story, because she is sort of held up as, this classic person who made a major contribution and was then overlooked. And even if we acknowledge that well, she had died. She was technically ineligible for that Nobel. It still seems funny to me that they included Maurice Wilkins, her colleague, not least because he did not like her. From everything I've read, she was a very assertive woman, and naturally that tends to make us unlikable, depending on the people you're around. And I've seen her described as like brusque and forceful. And so I don't know how much of this is just, the misogyny of the 1950s. And I find it interesting because, she was dealing with men like Watson, who racked up decades of racist, sexist, homophobic, anti-Semitic, even fat-shaming remarks. He made offensive comments about Franklin herself. But even then, I read that Watson originally wanted to talk to Franklin herself rather than Wilkins, but he'd pissed her off by implying that she didn't know how to interpret her own data. And even Crick later acknowledged, "I'm afraid we always used to adopt, let's say, a patronizing attitude towards her." So you do have to wonder how much of this, brusque personality that she was known for was just having to put up with this nonsense all the time.
Yes, yes, absolutely. I think, in science in general, you have to have a thick skin in order to succeed, because whether you're male or female, your theories are always scrutinized. So therefore, it's not for the faint-hearted, but it must have been even harder, at that time of, you know, in the 1950s, as you said, where in general it was quite unusual for a female to be in research, let alone make world-changing discoveries.
I found it interesting when I was looking at Rosalind Franklin's sort of earlier life. She came of age during World War II. So she was born in 1920 to a British Jewish family, and in her adolescence, her parents helped Jewish refugees fleeing the Nazis, including like housing two Jewish children. And then later in her final year at Cambridge, she became close friends with Adrienne Weil, a French refugee who'd been a student of Marie Curie's. Weil later helped set Franklin on her path to crystallography and the job at King's College. She patrolled as an air raid warden in Cambridge. You do have to wonder how much of that would have, shaped her as a child and a young adult. Um, and then, to enter the professional world with certain characteristics that have been impacted by those early experiences.
Absolutely. So I remember in Double Helix, or um, one of those other publications that Watson made, he was saying that if only she collaborated more, it would have been easier, for her to be accepted better. And that, I think this comes down to the experience in her life, that she had to be self-reliant. She had to do things herself, like patrolling as an air raid warrant. I mean, that is quite something that you have to have a stomach for, to actually do that. And this, I think, to me, really speaks to her strong-willedness and her self-reliant for doing things and discovering things herself.
And I will say, as someone who has studied a lot of women's history, a lot of times when women collaborate, they just magically don't get any credit for their work, especially in the sciences. So I would imagine as a woman in that environment, she was likely aware that that would have been a risk that um, as much as any, and she also just may not have wanted to, which is perfectly valid. But yeah, I would be a little leery of collaborating in that environment if I was a woman surrounded by men and seeing what
Oh,
happens
for
to other
sure.
women scientists.
I mean, even nowadays, people tend to not collaborate for whatever reason that they have around, the IP, retaining the IP, or wanting to make it themselves, or wanting to have the breakthrough epiphany themselves. Like, there are various amounts of reason that are perfectly legit to not collaborate. So therefore, trying to fit people into that mold that you have to act like everybody else is just not right.
And so if we want to fast forward several decades, you are doing work that I freely admit I do not understand. But it seems like you're harnessing computing technology to speed up research that helps scientists better understand and fight diseases, including analyzing the COVID-19 genome to help develop vaccines and molecular contact tracing. So could you tell me a little
Absolutely.
bit more about your work and how it works and what it means?
Yeah. So just like Rosalind was looking at the DNA through X-rays, we are looking at the DNA through the help of computers. So we're using supercomputers and distributed computers in order to make sense of the data. So we don't have to look at an image and calculate it by hand what it could mean, what the structure is. We're using computers in order to make sense of the numbers that we're seeing from the data, specifically around finding disease genes, for example.
Mhm.
So not falling into the same trap as as Watson and trying to explain everything with genomics, but there are clear risk factors obviously encoded in your genome that make you increase in, say, suffering from a um, heart attack or any other cardiovascular incident. And being able to detect that before symptoms appear, I think is going to be crucial to really have the preventative mechanisms or measures beforehand, before you actually have symptoms. And so this is our human genomics field. And as you alluded to, we're also working on COVID-19 genomes, so the virus genome. And I think relating again to Rosalind is that as a scientist, you like to contribute to many different areas with your expertise. And for the COVID work, we're sort of approaching it um, basically with a similar question: can we predict something from the virus genome that is influencing the disease outcome? So specifically, are there any mutations in the virus of the genome that could make a severe disease outcome or a mild disease outcome? And again, we're using computers and machine learning in order to predict exactly that. And we did find a lot of mutations in the virus, not only in the spike protein, which is where the vaccine is designed for, which is the most well-known structure or molecule in the virus, but in other areas as well. And one of those was shown to actually modulate the host immune response. And you can see how this could lead to a mild or severe outcome.
And you actually won the CSIRO collaboration medal for that. And it seems like going back to this issue of collaborating, I understand that you developed an open source AI-based cloud service that accelerates disease research. So I'm intrigued by the open source aspect because it does seem like scientists are a lot more productive and get things done faster when they're sharing information freely. And I think that's part of why we were able to get vaccines for COVID so quickly because there was a lot of sharing. So the open source aspect is the idea there. Just if we all share, then we'll all do better.
Exactly. Yes, because multiple brains together come up with more things than, the sum of their parts. But I think we are quite fortunate that nowadays, when we share things, there's a record of that, right? So it's not that you show the picture to a person and that person runs off and gets credit. It's there is a record of you having shown that picture, and therefore you can prove that what your contribution is. Therefore, I feel like hogging the results is less empirical nowadays. You do get the credit, and you can share the information openly, and we can build off of each other's ideas in a much more collegial, I would assume, environment that rather than what they were doing in the 1950s.
And there's also a lot more, I would say, venues to share information with. Like you don't have to, send someone a letter and wait possibly, weeks to get a response. It's just, oh, I'll just send that person an email. And like you said, like there's a record and everything. So it's not, I think the accessibility of sharing information is so much bigger now than it would have been 50 years ago.
Yeah, absolutely. So I think 50 years ago there were 3 or 4 journals, right, that you wanted to publish in, and therefore it was very hard to get into those. Whereas nowadays there's so many more scientific peer-reviewed journals that are of high quality where you can get your work seen, peer-reviewed, um, get the feedback from others. So it's a much faster cycle, I think, that we have. Of course, this comes with the downside of misinformation. And therefore, as a scientist nowadays, I think it's fantastic to collaborate, but you also need to know um, who to trust and how to collaborate with with those people. So maybe there is an element, after all, of you need to find the right people surrounding you in order to make impact.
What's that saying about a lie will make it around the world multiple times before the truth finishes putting on its shoes? Once misinformation goes out there, even if the person who put it out there in the first place realizes that they were wrong and tries to refute it, like I think probably the most famous instance is the refuted study that vaccines cause autism, which of course is not true. The author of that original study himself has repeatedly denounced those findings, and yet it persists. So it seems like fighting misinformation is just so difficult once it's out there.
Absolutely. So it's the most persuasive argument sometimes is sticking in your head. So this makes me think of why, because both studies were published at the same time, right? Rosalind Craig as well as Rosalind Franklin. Whereas back then as well, one was more hyped compared to the other. And one element to that surely might be that she was a woman. But I'm wondering how much of the way that things are communicated is sort of another element to it, the marketing of it, if you will. And someone who is really trying to get the beautiful math problem solved and demonstrated through that. Whereas in contrast, people that have the story right, that's sort of the two elements to it as well. And I think that's to this day, that's exactly the problem sometimes that you have, that you need to not only be right, but you also need to sell it the right way in order to get the impact.
People respond to pizzazz, not necessarily someone providing them with an informational lecture.
That's right.
And interestingly, the same thing happened to Nettie Stevens decades earlier when she and a man both published their findings about the sex chromosomes at the same time. And her work was actually more accurate. Like over time, it was shown that her findings were more accurate. And the guy didn't even study eggs. He said they were too fatty for his uh, for his
Yes.
microscope slide. So he just only looked at sperm. And yeah, he later like noted her when he published future papers. But he's out there getting sole credit when they published at the exact same time. And she's not even allowed to attend meetings where her own findings are being studied.
Yes. Yeah, isn't it interesting how it's so multifaceted? One is gender, the other one is marketing, right? And the third one is probably being at the right time at the right place.
So looking at genetics today, I would say CRISPR was probably like, at least in the from the mainstream perspective, it was probably the biggest genetics news of recent years. For people who weren't in the field, for us to actually have heard about something has to be pretty big news, I would say.
Yes.
And so, do you want to tell us about Emmanuel Charpentier and Jennifer Doudna?
Yeah, exactly. So CRISPR it exists in nature as of the immune system of the bacteria, right? So it's for the bacteria to fight stuff that is entering their cells. But Emmanuel Charpentier and Jennifer Doudna, they were studying this and they had the epiphany that you could use that mechanism in order to edit cells. And with that, of course, there's this whole new world of now editing the genome. So not only understanding it, what we've been doing it for decades, now we are in the position of making actually changes to the genome to reduce disease risks, for example, or potentially eradicate genetic diseases altogether. And of course, then in the biotechnology space as well um, to edit certain cells um, for example, detect pathogens in a um, in a biosensor kind of way rather than through mechanical detection. So with that, CRISPR is really, I think they were saying that it's the discovery of this century. And when you think of that, there's computers and there are the other things that really have changed the way that I think our world works. But CRISPR really has the potential to taking that up a notch. Yeah. And therefore there obviously was this contested area who actually did the invention, right? Who should receive the patent for it? Because when you think about it, that's a multi-billion, trillion-dollar kind of entity. And therefore, the Broad Institute and Berkeley were in that contested lawsuit around who is actually owning the patent. It got settled similarly with the Nobel Prize, and the Nobel Prize were following shortly after that of awarding that innovation or the detection of that to Emmanuel Charpentier and Jennifer Doudna, which of course wasn't an easy path, right? So they're with a lot of marketing and trying to sell the right thing at the right time, elements to that as well. Where the Broad Institute were trying to publish an article saying these are the heroes of CRISPR, and they left strategically Emmanuel and Jennifer out of that because likely of the lawsuit that is raging underneath all of this. And so it comes back to that nothing is really black and white. Everything has so many layers to it, and gender being one of them. Um, being uh, in a fortunate position that we're in nowadays. Even in that scenario, there are winners and losers.
Yeah, and I think it's also a question of, from a marketing standpoint, the flash of brilliance story is very appealing. Like, we love this idea of just, a genius having an epiphany, but it does seem like most science is not that. It's a lot of
Yes,
hard
absolutely.
work and processes and trying things, and that didn't work, so we tried something else.
Absolutely. So from my perspective, it's so hard really to attribute a certain discovery to a certain person or group of persons, right? Because it's hard to really determine when was it discovered and what was just before that discovery, what has happened there, who has said what that sparked an idea and so on. So yeah, it's science is incredibly messy, but we like to tell stories, and it's easier if stories have heroes, and therefore we're always coming back to those individual heroes just for the sake of the story.
Join us next time on the Infinite Women podcast, and remember, well behaved women rarely make history.